Hi and welcome to another video for Maths D Year 9. So today we're going to do bounds of measurement in terms of the sums and the differences. So here, what's the purpose of this is because you want to find the least possible value and the greatest possible value. Now, from here, you have the least possible value. So what I'm going to do is when you have the lower and the upper bound, you are going to do either two of these operation. It's going to be sum or difference. So to get the lower bound, which is the least possible value, you have to add the lower bound. Okay. So similarly, for difference of measurement, to get the lower bound, you have to subtract lower bound of the larger value, and then you have to subtract from the upper bound of the smaller value, right? So you have to remember that. Okay. And then what you are going to do to find the upper bound. So when you want to find the upper bound, you have to add the upper bound for the sum. Okay, and for the difference, to find the upper bound, you have to subtract the upper bound of the larger value, and then you subtract it with lower bound of the smaller value, right? So let's see here. Okay, consider these two boxes. Okay, they have widths of 300 millimeter and 500 millimeter, correct to the nearest millimeters. So here we have to find the error first to get the lower and the upper bounds. So nearest millimeter should be yielding half of millimeter. So this is going to be plus minus 0.5 millimeter. So from the absolute error, you can find the lower bound and the upper bound. So here for lower bound of width, with this box with 300 millimeter, lower bound will be 299.5 millimeter, and the upper bound will be 300.5 millimeter. And for the 500 millimeter box, you will get 499.5 millimeter, and for the upper bound for this one will be 500.5 millimeter. Okay, simple calculation. Now let's consider if we are going to put the cupboard next to each other. So when you want to find the total, so what you're going to do is you find or you add the bounds. So you want to find the lower bound. So when you want to find the lower bound, you have to add the lower bound. So this is the smallest possible value. Okay, now when you want to find the upper bound, of the sum, you have to add the upper bound. So this is the biggest possible value that you can get when you try to join the box together. So when you want to find the lower bound, so you have to add the lower bound together. So from here, the 300 millimeter box, 299.5 millimeter, plus the lower bound of the second cupboard, so 499.5 millimeter, and when you add them together, you will get 799 millimeter. So that's the lower bound of the joint width, or the smallest possible length of the joint width. Okay, let's move on to the upper bound. So when you want to find the upper bound of the joint width of the cupboards, you have to add the upper bound from the first one, which is 300.5 millimeter, added by the second one, which is 500.5 millimeter. So when you add them together, you will get 801 millimeter. Okay, so that's for the first aspect of operation, adding bounds. Okay, right. So next one, if we need to find the difference between the width, so when you want to find the lower bound of a difference, so what you're going to do is you have to subtract the lower bound of the first one, I mean the larger value, and you have to subtract it with the upper bound of the smaller value. You have to remember this. So lower from the larger and subtract it with the upper of the smaller. Right. Okay. So to find the upper bound of a difference, all you have to subtract is subtract the upper bound of the larger value, and then you have to subtract it with lower bound of the smaller value. So, okay, just to fill this in. So from the box just now, if you want to find the lower bound, you have to use the lower bound of the bigger one, which is this one, subtract it with the upper bound of the smaller one. Okay, and then to find the upper bound of the differences, you have to use the upper bound of the larger value, subtract it from the 299.5, which is the lower bound of the smaller value. So just fill this in. Okay, just follow me through. So here you will have a lower bound, right? So 499.5 millimeter, which is the lower bound of the larger value, subtract it with 305 millimeter, which is the upper bound of the smaller value. So when you subtract this together, you will have 199 millimeter. Okay. Now for the next one, when you want to find the upper bound of the width difference, so the largest possible value, you will have to subtract the upper bound of the bigger value, the larger value, which is 500.5 millimeter, subtract from 299.5, which is the lower bound from the smaller value. So the difference will be 201 millimeter. You can see here the lower bound is smaller than the upper bound. Okay, now let's move on to the next one. Okay, next one here is you have example 1. Okay, a piece of red string is 35.2 centimeter long to the nearest millimeter. So here, let's figure out the error first. So the absolute error will be, okay, let's look here. Since you have millimeter as your unit of accuracy, but your measurement is in centimeters, you have to convert this into centimeter, right? So I have given the side note over here. 1 millimeter will be 0.1 centimeter. So 0.1 centimeter, and then you have to divide it by 2 because you want to find the error. So the error will be plus minus 0.05 centimeter. Okay, now for the next one, a piece of the blue string, okay, 12.6 centimeter long to the nearest millimeter. So you're using the same error. Okay, now let's find the lower bound of the red and the blue first, right? Before we solve the problem. So over here, okay, I will just use my own table. So I will use here for red, and then for blue I will arrange like this, and I will find the lower bound and the upper bound for each string, right? So what you're going to do is the lower bound of the red string will be 35.2 minus 0.05 centimeter. So you will get 35.15. And for the upper bound, you have to add 35.2 plus 0.05. So you will get 35.25. Right. Next one is for the blue string. So for the blue string, you have 12.6 centimeter measured. So the measurement will be, to get the lower bound, you have to subtract the 12.6 with 0.05. So you will get 12.65. And for the upper bound, you have to add, so this one should be 12.55. Okay, and then this one will be 12.65. Okay, now what you're going to do is to answer this question. Minimum length. What is the minimum length of the two pieces laid n by n? So here, when you combine them, you are basically adding them, right? So when you are trying to add them, the question asks you to find the minimum length. So this is basically asking about the lower bound of the sum. So what we're going to do is lower bound, or the minimum length, okay, minimum length of the two pieces, right, will be lower bound plus lower bound, right? So lower bound plus lower bound will be what's the lower bound of the red? So the red one will be 35.15, and then add it with lower bound of the blue one. So the blue one have 12.55 centimeters. So your final answer will be here 47.7 centimeter. So that's the minimum length of the two pieces laid end by end. Okay, so let's answer B. So for B, I will use another color. So what is the lower bound of the difference in the length? So you know that the difference, okay, lower bound, I'll use LB, of difference will be, we start with the lower bound of larger value, right? Okay, if you remember. And then you have to subtract it with the upper bound of the smaller. So let's have a look here. Okay, which one is the larger one? The larger one is the red, so you have to use the lower bound of the larger, which is the lower bound of the red. So the lower bound of the red will be 35.15, and then you have to subtract it with the upper bound of the smaller value, which is 12.65. So when you try to subtract this, you will get, okay, 22.5 centimeter. Okay, so that's for example number 1. Okay, let's move on to the next example. Okay, next example here, this is taken from a passive paper O level, Maths D, paper 1, from November 2000. Okay, let's have a look at the question first. Okay, the length of a side of a square is 12 centimeter. Correct to the nearest centimeter. So there will be an error over there. So let's read the question first. Complete the statement in the answer space to show the smallest and the largest possible value of the perimeter of the square. So here, when we are talking about perimeter of the square, you have to add the sides. So let's illustrate this first. Okay, you have a 12 centimeter square, so you have to 12 plus 12 plus 12 plus 12. But here, since you are dealing with upper and lower bound, so you have to find the upper bound of the sides first, right? See the bounds of the the sides. So here, nearest centimeter. So here you will have to plus or minus 0.5 centimeter, half a centimeter. So that's your error. So let's label the lower bound first. Okay, let's find out the lower bound for the side will be 12 minus 0.5 will be 11.5 centimeter, right? And then the upper bound for the sides will be 12.5 centimeter. Now, when you want to find the perimeter of the square, okay, let's do the lower bound first, which is the smallest possible value of the perimeter. Okay, I will just call it the smallest perimeter will be, you have to add the lower bound. So 11.5 plus 11.5 plus 11.5, and then you have to plus 11.5, or you can just multiply 11.5 by 4. So here the smallest perimeter will be 46 centimeter. And lastly, the largest possible perimeter will be, you know it already, you have to add the upper bound. So 12.5 plus 12.5 plus 12.5 plus 12.5. So when you add them together, the largest possible perimeter will be 50 centimeter. So with this, you have to complete the statement over here. So here will be the smallest perimeter and here will be the largest. So I'll just put here 46 centimeter is the smallest, and the largest possible perimeter will be 50 centimeter. All right, I think that's it for the sums and the difference of measurement. I hope that it's quite simple to understand. Thank you very much and see you next time.